Hello and welcome everybody to my talk, Building Your DevOps Pipeline on AWS. I didn't know that this fits very well into all the things you have heard so far about continuous delivery. My name is Mark Rambo, as you just heard. I'm Software Development Manager for the AWS OpsWorks for Puppet Enterprise team out of Berlin. So our talk today will be around developing and especially testing and deploying your Puppet code. And that's more important, especially if you have a guy like Jeff coming in, deleting 90% of your code base and still promise it works. It will show you how to build continuous delivery and integration pipelines on AWS. And one important aspect for that is how you manage your credentials. To give you a sneak peek, this is where I want to end up today with you. This is a representation of a fully automated AWS CodePipeline that tests and deploys your Puppet code onto your Puppet master. But let me start from the beginning. So you might ask, why should I care about continuous integration? And I think you have heard a lot of reasons already, but I want to emphasize on that you want to test your code before it goes into production. And you don't want to rely on habits and good intentions that every developer will test the code locally. That doesn't work. Especially if you work with multiple people in teams across the globe, you can't rely on that habit. And you want to just make sure that nothing is going out to production that is not tested yet. And what you also want is to have good insights into which state of the code is currently on my master and what is running on my Puppet nodes. So the goal for every company is to drive securely and fast. The system on the right is very flexible, constantly adapting to ever-changing requirements. Accidents are rather small, so you have little bumps here and there, nothing that is too serious. It is very organic, and it can adjust to the cars that go through. If there's a big truck going through the picture on the right, it will work. Change is anticipated, and it's handled with a few rules only, and with a reactive approach. This is, to my experience, how systems actually evolve over time. There's always changing requirements, and you need to adapt to it, and you're constantly delivering small increments of change. The system on the left is beautiful. So as a German, I really love that one. It consists of many, many rules. I also like that. And it is there to achieve speed. Because if everyone is having the same set of rules, everyone can rely on each other. The problem is, if an unanticipated accident happens, the whole system comes to a full stop. And this is what you need to actually deliver software to production, because you want, if something is detected that doesn't work out, that the full pipeline is stopping and nothing is going to be released so that you prevent issues in your production system. So there are some key aspects that I want to focus on. Code needs tests and should always be automatically tested when a change happens. Infrastructure as code, especially when you're using Puppet, or when you're using something like CloudFormation or Terraform to actually define the state of your public cloud. I'm from AWS, so I'm in the middle of that. You want to enable teams to work safely together, and you want to stimulate shared responsibility by having code reviews and having peer programming and all those kind of things. And what you want to have at the end is confidence in the code that you're building. The more steps you introduce into the process and the more rules you introduce, the more confidence you need to have in the code that is going live. So each team we speak to has a different release process. And that is to accommodate their needs, right? So some companies have a long, long pipeline with a lot of steps in between, a lot of checks, compliance regulations, and all that kind of stuff. But at the end of it, you can map it to about 4 steps: source, build, test, and production. And each stage must increase your confidence in your deliverable. So the first stage, this is where all your code is written. So you check in the code to your Git repository. Ideally, you have a pull request, you have a peer review, or you do pair programming. Most teams that I know do a mix of both, so that no code is going out that is not seen by someone else. The build step, this is where the quality in the code will be assessed. This is a lot of linting, parsing, compiling, style checks, and also unit tests. And so everything that can be done on a single build machine is in that build step. The test phase, this is the one where the interesting stuff happens. So you've seen a lot of things with delivery on Puppet, where you can assess which changes might happen in production and so on. But this is not all that you need. What you need is you want to make sure that you have integration testing with other live systems. You want to have load testing. You want to have UI and penetration testing. And load testing, this is the aspect that is the most interesting for me. So I guess that many of you change things like JVM settings, inodes on this disk or on the system, or the number of connections that are allowed on your MySQL database. Doing those changes in isolation look fine. If you give more memory to your Java process, or if your Java developer says my Tomcat needs more memory, that's great for him. But there's also the Splunk thing running on that same machine that actually likes that memory also. So you want to make sure that the change that you anticipate and that you roll out is not having any side effects. And for that, ideally, you have integration tests that check all those things against the application that should run on the system, not only the system changes that you do. So at Amazon, we deploy to multiple stages before we actually end up in production. So ideally, all code is going to dev, beta, gamma, pre-prod, and then we roll it into waves into all our regions globally. Right? So my service is running in 9 regions. Until we have the last region deployed, we go through different iterations to see if there's any issue, because no one is or can anticipate how production systems are used by real people. So we want to make sure that nothing is hitting everyone. So we want to make precautions and having that rolled out slowly. So with every one of those 4 steps, you build the confidence in your deliverable, especially if you do load testing and integration testing in the test phase. Your production deployment doesn't look so bad anymore, and you feel confident to actually do it. So this is bringing us to continuous integration. Continuous integration is something that is around for, I would say, 15 years. And it got more and more over time. So more people adopted continuous integration because when I started doing my career, people were having changes isolated on the development machine for weeks before they actually integrated that with production. And then there was a big integration project happening in my first company. And that integration project was up for about six months or something like that. And I didn't understand it. And over time, I understood that the people that were working on that project were not integrating the code over and over again. They just waited until they were done, and then they tried to make it work. And merging business logic together is already a hard job, but merging test logic over is difficult. So having something that is hard and difficult, you don't want to do that only once. You do that over and over again so that you have small increments. So continuous integration is a practice that many teams make more productive, and that lets you develop software faster. And in your case, you develop Puppet code faster. So it means that more improvements go out to your production systems right away. And you get feedback maybe from your mobile app team that now the backend service for their mobile app team is performing much better. So great. There are multiple different definitions on what continuous integration is, but most of the teams that we talk to at Amazon, they say continuous integration stops at the build step. The next one is continuous delivery, and this is actually going all the way through even until production, but most of the teams have for continuous delivery this one manual blocker. You've seen that also in one of the demos earlier, where you want to have one verification step or having at least kind of consent that this can go out to production. If you're able to automate that manual approval away, then you go into continuous deployment. And for that, you need to trust your test to actually cover everything that you would test manually yourself. And all customers that get into that stage actually can continuously develop software, and they are confident that their pipeline is testing all aspects of it, being totally sure that everything that is running in production will work. To come to that state, this takes some effort in the beginning, but it makes you a lot more productive. And most teams at Amazon are actually in that state that we are continuously deploying everything to production to our customers, and we can trust our pipelines to catch everything that should not be there. And because at Amazon, we started building software 20 years ago, at least, And we built some services in-house and for Amazon that we also released as AWS services to our customers. And those AWS code services, that's easy to work with Puppet. So we have our own Git equivalent, that's AWS CodeCommit. You can also use GitHub, GitLab, I don't care. It's just you need to have something to store your code. The next thing that I would like to emphasize on is AWS CodeBuild. This is beautifully simple. It just has one script that says this is what should run in my step. And it is very easy to configure, and I will show you that in a second in my live demo, if the demo gods are nice to me. I can also use CodeBuild to actually plug in the Puppet parser, Puppet lint, RSpec Puppet, and I think that Jeff might have some other ideas what you want to test before you actually get that out to production. And then Puppet code deploy is great. If you have, or if you're using R10K to use on your Puppet Enterprise server, Puppet code deploy lets you upload your Puppet code to your server. If you use Puppet open source, you just need to somehow copy the code over to your Puppet open source master. However you want to do it, that's up to you. But CodeBuild gives you the way to just script that up and automate it. So if you have all those 4 steps, every single one of those stages can be automated singly. But you want to have some glue codes that puts it together. You want to have something that is, we use CodePipeline. Could also be your Jenkins or anything else that you have already. But because we are AWS, we want to talk about the tools that we have because we are most familiar with those. So CodePipeline will make sure that there's a code change triggered on GitHub or on code commit. Then the next stage will be pulled off, that is CodeBuild, which is starting a Docker container, runs all the tests, tears down the Docker container for you, and progressing towards the next stage. In my demo, I will use AWS OpsWorks for Puppet Enterprise, which is a fully managed Puppet Enterprise server in AWS. You can set it up with just doing, I don't know, 3-4 clicks, and then wait 20 minutes. Your Puppet Enterprise server is running in the cloud, is fully managed, always upgraded, always patched, constantly monitored. And we also give you a starter kit. And what's in the starter kit is your workstation configuration. So everything that you need to actually start working with Puppet is already there. You also have an example code repository, control repository, that you can use to actually set up a nice demo within minutes. It's just an Nginx with a static website, but at least you get started easily. And the thing that is the most interesting is a user data that we ship with the server. The user data lets you use AWS to make a node association between your node and your Puppet master, and you can rely on AWS IAM to actually make sure that this node can also talk to that master. So you can set that up with all the routes that you have in AWS, usually in IAM. You can just say, okay, all nodes that are started from that person can also connect to that Puppet master. So that's cool, because what you can use with, what you can do with that is that you have unattended node association, meaning you can integrate that user data script in your Terraform, in your CloudFormation, in your AWS autoscaling group. So if you have a load event where a lot of customers coming to your new site, it will scale out. It will start new instances for you, and they automatically connect to the server, being provisioned the way you like them, and they can handle the load for you. And all that without any manual intervention. You don't need to think about provisioning them beforehand, connecting them, making sure that they are deploying the right thing. Everything is working for you, so you don't have to take care of it. And that is especially interesting when you have a load event that is in the middle of the night in your time zone, somewhere else on the globe. And with that, I would like to go over my demo, and I want to show you what I have in my demo. So I use some code from my starter kit that I got from my Puppet Enterprise server on OpsWorks that has the configuration to know, okay, this is the server I want to talk to in my pipeline. For Puppet code deploy, you need to have a token so that you can talk securely with that Puppet master. And I store that in parameter store, which is a secure storage in AWS that you can use to store credentials, for example. And then I have a code commit. This is where my Puppet code is, my control repo. And I use CodeBuild to actually go through my tests. And CodePipeline is actually merging that all together. At the end, I deploy it to my Puppet master on OpsWorks, and my nodes will get all the code. And with that, I would like to hand over to my demo. Great. There it is. So let me see. There's my mouse. Cool. OK, so this is my pipeline. This is what I want to show you. And as you can see, there's already this is the code commit step. This is where my code is living. And 3 hours ago, there was the last checkout from here. It ran all my tests. They succeeded, which is great. And there's one approval step for the upload to my production environment. So what I can do here is I can check on the source and see, OK, there's one revision. It says better headline, whatever that means. I can click here, and it shows me the change and code commit, and says, OK, instead of Puppetize, it says Puppet loves continuous delivery. I think that should be good. I can go back to my pipeline. Wait, to my pipeline. Wait a second, where's my pipeline? There it is. No. Sorry. OK, this is my pipeline. And it says, OK, this is a very simple change. I can just give it a ship it. And I think we're good to go. I can just approve it. And in the next stage, it does code build upload, which is Puppet code deploy. That will upload this change to my master. And then all my nodes will get it on the next check-in. So that pipeline looks very, very simple. And let me get over that here. So this is my control repository that I got from my OpsWorks server. I can see here there's the config that I need. Here's my token in there. And here's my repository example. The things that I added are those build spec files. Build spec are used for code build to actually say what should be done with that stage, right? And as you can see, this is just a couple of lines of code that is doing the parsing and linting automatically. So I don't need to actually ask all my developers to parse and lint all their code. This will run in the pipelines, so no one is getting anything out there that has the wrong hyphens, not well-formatted code, and so on. But there's a lot more you can have here, right? You can have RSpec in here. You can have a lot more tests in here. Whatever you think is necessary to actually make sure that the code is looking good, you can add here. And the other one that I have here is the build spec for the upload, which is using my from S3 the credentials or the configuration. Then it will unzip that. It will download the SSL certificate in the 5th line, and then it will use the access token that I got from my setup, putting it on the box in that one file, using Puppet code deploy to all regions and all environments. So what you can do here is, just for the demo, I just said I want to deploy all environments, and that will also update my production environment. What you want to do usually is that you have multiple stages, right? I talked about that you want to have a development stage, a staging system, and then going to production. So you can have multiple of those steps, deploying first to your staging environment, then setting up a new cloud for that looks like your production environment, so that you can say, OK, the change that I did to my memory settings on the JVM, they don't impact the rest of my application. You can run load test against something that looks very similar to your production environment, tear that down in the cloud because you only pay for as long as you need it, and only after those load tests actually succeed, you then want to push out the next stage that is deploying it to the production environment, and you can be sure that all your applications are still running fine. So if you do a lot of performance setting changes and so on, you want to have that automatically covered. What would you do otherwise? You would launch it on one node, or you would deploy to one node, see if everything looks good. You do a lot of manual changes. You don't have to do that. You know exactly what you would test. You can automate it. And this conference is all about automation. So this looks very simple. And my example is just a static website. So bear with me. It's not that I do a lot of great Puppet code here. Also, that's not my main focus. So I just changed this one line in HTML or in my ERB template here. Puppet loves continuous delivery for real. So, much better headline. What I also have here is that I use a trusted fact that pushes out the host name so that I can show you behind my load balancer which node is actually having that. And why that matters, I will show you in a second. So, and then you do the usual dance. I will just commit another better headline. I'm a bit lazy today. And I push that to my code commit. That's about it. So if I go back to my browser, in about a minute or so, the code commit step in my pipeline will kick off, seeing there's a new change, running all the parsing and linting, see if everything is fine, especially if you change some config files that you really want to do. And then it goes all the way through until the approve upload step. So I don't have a continuous deployment pipeline here because I don't trust my testing. Just parsing and linting is not good enough. It goes all the way through the manual approval steps that I showed you earlier. And then it only goes to production. So if I go to my page here, so you still see hello Puppetize, right? And that is because my Puppet master didn't kick off the node run here. Oh, great, I need to log in back. I love that. Fine, great. Okay, so that's my overview. You can see I have two nodes, and if I just reload, you can see here the node ID is changing. Let me increase the font a bit. So that's all you can see, right? This is my instance ID, and it comes from two servers. If I now run on one of those nodes, Puppet, it will get me the newest headline, and that will probably just take 10 seconds or so. Okay, so now I can see one node is having the new changes, the other one is not, right? So that's cool. So that change went through my pipeline. I did the parsing and linting and all my tests. I did load tests and everything that I wanted to have. And then it will be deployed to my production environment and getting to the nodes on the next node run. That's cool. And that's actually already what I wanted to talk about. So if I go to my pipeline again, you can see the source code was already checked out. Now it's running the code build step. And the cool thing about code build is you can see that in action while it's running. Probably I was a bit late. But you can see what it did, right? So this is the linting and parsing stuff that was just running. And if one of the parsers or the linters are not happy with your code, and I had said a lot of times because I'm a bit messy when it comes to indentation and so on, it will just break my build and say, that's not good enough, do it again. So I just checked in another version of it. It will tell me if my code looks fine, and then it's progressing to the next step. Going back to my pipeline, you see there's a new approval. That's cool. Should not log out myself. So that's the news headline. I can review that. Say again, great. Because I'm the single developer, that makes no sense at all. And on the next step, it will go to the code upload step, uploading it to all my environments. All my nodes can have it. Let me get back to my slides. So this is what you have seen, right? So I just have in my code build one step that is linting and parsing everything, and another code build step that is uploading everything to production. And my pipeline is taking care of all the changes going from code commit or from your Git server up until my Puppet master. The Puppet master can be on OpsWorks, can be also on-prem, can be in another public cloud. We don't care. that is completely up to you. You just have this one line that says, this is how I upload my stuff to my Puppet master. And because this is a lot to set up, we made just a blog post, and we got that done before the conference. So all the codes that you've seen here, it's just one click away. You just can either scan that ID tag there, or you just remember that bit.ly URL there. So you have all the codes that sets up everything in production on AWS. You have all the build steps there. You can adapt them if you want. You can either use an OpsWorks server, or you can use your on-prem server. You can start with continuous integration of everything that you have right away from that one post. And with that, I'm in time. Thanks a lot.